Good morning. Yesterday we finished up with comp time keyword, and there's a lot more to it, I found out, but that is for a later time. Right now we know it exists, and it's something that can be used to create stuff at compile time. So here we do some calculations and set the x const to that value. So at runtime, this is not called because it's already been done at compile time. So x will just have the value 55. So that saves some time at runtime if you have some kind of constant you can calculate. Moving on, payload captures. Let's see. Payload captures uses the syntax pipe value pipe and appears in many places, some of which we've seen already. Yes, we have. And it is something that I need to get used to because that is not something I've seen before. It's probably in other languages, but I haven't seen it. However, wherever they appear, they are used to capture the value from something. With if statements and optionals. Let's see. We have maybe number. It's a nullable usize equals to 10. If maybe num, and then we capture it. And says, if that is true, then take that number from here. So now n equals this, I guess. Type of n is usize, yes. And the value is 10, else unreachable. This should never happen because this is not null. That's the only thing it checks. It doesn't check the value. If it's a 0, it will still be a true value. Or evaluate to true. Yeah. So that makes sense. With if statements and error unions, the else with the error capture is required here. Okay, we take it one more time. We make an error called unknown entity or a unsigned integer 5. If exactly the same thing again, we have the value, we capture it, checks if it's the if it's not null, check the type and the value, else capture the error. And then use the error. How does it know if I have multiple unions of different types here? How does it differentiate between the value and the error, or is that just something special? With if statements and error unions, can we have multiple return types? I think we could, right? But what if we have, can we actually have different types besides errors and types? I guess not. Okay, moving on. Yeah, I'm probably like everybody else, losing a bit of patience. I would like to get on with the project and do something more hands-on project, but we still need to go through this. I just want to clear the chat. Pause chat, delete messages. clear chat. It's been cleared. Yes. I just did some test because I still can't figure out how to delete a message, but apparently it's something about the mod mode and having icons that actually displays a delete button. I'll figure it out. So far, no, only one has actually written something in the chat that shouldn't be deleted, and we had just as many spam messages. So 50-50. With while loops and optionals, this may have an else block. A sequence of something, an integer usize I, while sequence of I get that number. Sequence. Okay. So we have a function, a lookup into this table. At the first time it will be ff, and we will have that number here, but we can still do this. So we have kind of an index, and this was what did they call it? But it's called at the end of the block, right? We will test. We haven't done any today. Yes, I know. This works. Yes, it does. And what? The output. Pretty sure you can take this. Just check what I is. And that's a number. And we want to do it for I. Replace this one, save it, and run it. Not once, but twice. Still I don't get debug print outputs in the tests. I find it really weird. So I can't really check anything. Find it that sometimes I do get an output, because where I copied it from, we did get this output, right? Yeah, this one writes out stuff, and it's the same print method I'm using. Kind of strange, right? Again, small details that in my mind should just work, and I don't know why it doesn't work. Because this is so basic. Output something to the screen and nothing happens. Standard debug print. Yeah, because the the normal way to output to the console doesn't work in debug mode, right? You can see I've used it multiple times. And there again, it just prints out the value. Then why doesn't it work for this one? Oh my god. What is the difference between starting it like this and like this? Seriously? Well, whatever. So I can't really use this. Right click for more option. Run test. Run test. Can I do it? Run debug test. Oh. Yeah, the debugger isn't running or working, so let's see. There's run test and run test. Why are there two options? Run test and run test. This works and this does not. That is weird. I guess that, do I have some run test set up in? No? Then that is weird. But okay, if we can just right click here and say this one, then it's absolutely okay. So as we can see, I isn't increased at this point, or at the end, it's increased at the end of the block. So it's actually back here. So that was right. Let's just keep that. So that was right. So we still do the capture here and have it available inside here. If we needed this information, we would have to first make a variable, set it to the first element, start it, and for each time we need to access it, we would update that variable by running this sequence. So this saves us a few lines of code actually. With while loops and error unions, the else with the error capture is required here. It's required. Well, let's run the test and let's run the test. What? This one only has one option to run the test. This down here has two. What's the difference between these two? I don't see any differences. Yeah, I have a debug print statement, but that shouldn't make a difference. But okay. that's so weird. But okay. Moving on. While error union capture, we have an unsigned int, numbers left. That's a global. Eventually error sequence, capture a value. This one So this eventually error sequence will eventually give us a reached zero error. But how does the compiler just know? Because it has this, so it knows, no, it will return an error. Yeah. So what about this? Yeah, it will say that expected type U32, but it returns this one. So now this will be handled because this can actually now return an error as well. But when we capture the value, we do it on the while. But if that fails, evaluating this, it will go to else and capture the error. Because this isn't a value. So are errors also evaluated as a false statement? Or is this a built-in else only based on this? I guess it is. Can we try to do something like, let's copy a print statement. I just want to check if an if statement, if error dot, yeah, access denied, that would evaluate to false value, right? So can I just, do we actually need the curly brackets in SIG? It looks like it. Error equals true, right? Or does it evaluate to false? What? While error union capture. But we didn't touch anything down here, right? Is it because we are working with error? It needs to... Yeah. Maybe it is. It doesn't like us just accessing this expected type boolean. But I feel like that is what this is actually evaluating. What's it saying? Yeah. So we can't just check on... Huh. I had the feeling that I understood this, but apparently I do not. So I can't evaluate on this one? No, I actually can't. So it's not that variables can be checked, but I just feel like we did. But I guess that we can only do it if we actually have a function call that can return 0. Or maybe if we set this to this, is it then a valid question to see if... Damn, it's the simplest thing. Just an if statement to check if a number is a number. Have I already forgotten something we went over? I might have. But again, I need to work with it. So let's get to that point a bit faster. And let's look at this again. Now what did I mess up? Did I delete something? Yeah, I deleted the first line here. There we are. Yeah, okay. So it evaluates this function, but if this function returns an error, we can capture it with this and do something with it. Fair enough. For loops, for loops, for loops, for loops. Yeah. For each element in X, capture V and check that V is of type signed 8-bit integer. Switch case on tagged unions. Tagged unions. What's a tagged union? We have a union, enums, and it can hold different objects. We set it, we create a new object of type info, and we set the value A to 10. We switch on B, which is now this object. If we have B, then we can capture it as a string, not a string, just capture it. And in this block, we try to check if type of this str variable is of the type array of unsigned integers, and it is, and we break and return 1 from this block. And when we break and return a value, we have hit this, and X will be 1. Switch on C value. So if C, no, we switch on B. We switch on the value 10. Wow. As I said, it's more about the new syntax. It's the new look of the code. It's the way it's written. It's the syntax itself that's harder for me to read because it's not familiar. Why is this not working? What is it on about? Expect. Did I copy in this again? Yes, I did. Now that works. Again, let's get some information out of this code and see what's actually going on here. We can just say something like this. Same here. And 2. And D, do something. Come on. A and D, C, and let's see. It goes to A and D. If these are the same type, they may be inside the same capture group. So again, we are switching on the B value. B is of type info. What do we set? We have set A to 10. So we're switching on the object here. We're switching on info. And we're checking. See, there I would have expected to see something like this to get the actual value of that. But we're switching on B. So we are taking b.b. Can we just call it something else? Call it swish. Swish. Just to differentiate that B and that B. So we are switching on the object. And if .b, so it's actually switching on these types and checking if they're set in a union. And currently we have set A, so we will be down here. If we instead set C, but C isn't even defined. What kind of an object is this? It's kind of weird. A and D, what if we say B? We can't do that, can we? What, how would it, yeah. How would it convert this const 8? So we can set it to a const u8, and how did we u8? Again, syntax. I have to remember the syntax. Can we just do this? No, we cannot. Does not support array initialization syntax. Of course it does. We can always make an array of numbers, right? How is it? But it shouldn't be nullable. It should just be this. Why can't I do this? And even give it this to just indicate that this is 1. This is gonna take some time. I'm sorry, guys. But that is actually this I wanna show people, that small details can really take time to understand when you're not used to looking at this form of this, yeah. A new language, new layout, new structures, new syntaxes. Because this should just be the most simple thing ever. Because this to me is the same as what we just have. The only difference is the const. And we just add 2 values. So we initialize it exactly the same way. The length, the type, and the values. So what is it doesn't like here? Array literal requires address of operator to coerce to slice type. Seriously? No, of course not. Can we just do a slice? We cannot. Okay, I need to get this working. I just want to initialize and a const array. Or is it because this is defined as a type, no data at all? That's not what we're talking about. See, again, I need some people in the chat to help me out here. Yeah, because this is exactly what I would expect to just put in there. No, it's not mutated. Oh, so we can use const. Yeah. Again, const versus var. In Kotlin, it's val or var, value or variable. So I know the concept. Again, it's a different syntax. Requires address of operator. Return error, test unexpected result. I just wanted to enter this one. Const u8. So what are we actually doing? We are allocating 3 integers and we are pointing b to that, because to me this is a pointer to an array of u8s. So why can't I assign this? Oh, I can, but it fails in line 14. It's actually saying this is the try x equal 20. But where do we set this x value? We set it up here. Oh, so it's actually requesting this number. Okay. And right now we are entering this one and return 1. So it's actually, oh my god. It's those little details that the test is written to only be true if you hit the right switch results. And I think that this is the error, but it isn't. It's actually because these returns different values and the test was written for a specific one. But this taught us a bit about this notation. So it's actually testing that the type of B is a pointer to this array type of unsigned 8s. So this will probably fail if we say 16 instead. And this will fail because here I try to assign the B pointer to the data, which is U16, and we set it up to B and 8. Yeah, cool. That was a rough one, even though it actually is a simple switch statement. But it's kind of nice that we can figure out what's actually in the union. Else we would just have a memory layout of something and we wouldn't know if we should read A, B, C, or D. As we saw in the union and optional section above, values captured with the val syntax are immutable. Okay, so when we get this information, that can't be changed. Similar to function arguments. Oh. They can't. Okay, we'll see about that. Is that because we always... No, if we get a reference, we can change the data at the reference point, but apparently we can't change the reference itself. Maybe. Again, this is not a tutorial, remember that. I'm fumbling around here, I'm learning, so don't take anything I say as a valid statement about sick at all. Let's see in a year or something. No, hopefully not, a couple of months. Then maybe I can make a statement about sick that is actually true and validated. Are immutable, but we can use pointer capture to modify the original value. Okay, this captures the values of pointers that are themselves still immutable, but because the value is now a pointer, we can modify the original value by dereferencing it. Let's play around with stuff once again. And we have yet another equal function. It's probably the same, but to make sure everything still works, let's just make another one. We have some data for how was it? This should be the address, right? Or is that the pointer? Again, I'm not used to working with pointers and addresses. So maybe we could just add a print statement and figure out what values are in here. Let's say, for instance, we would like to print out this one. The arguments, that data in here as a, decimal, I guess. And what would this contain? That we cannot do. Use of undeclared identifier byte. Const pre-data equals this one. And then we can use this one. Let's see what it outputs. Error. As always when I touch anything. Invalid string format D. We can't output D for this line 5. Come on. So it's one of these, but I would expect it to tell me which line. 3U8s. Maybe it's this one. It's a 50-50% chance, right? No. Come on, help me out here. Invalid string D for type, pointer to U8. So how do I print out this one? Or can I just omit that for now? I can't even print out that one. Let's go back. We have this thick language here, learn, language reference. We had this list of, there it is. And we don't have anything that can print out this. No. So it's the details of how to print out stuff. But I really have to look at the pointer part again. Because this, I'm a bit confused about addresses and content of addresses. But I guess that this gives the address, this captures the value at that address, and then we access, no, don't listen to me. Data contains that, yeah. And the ampersand is what? Pointers. Referencing is done with this variable. Dereferencing is done with the variable dot. So we're just referencing, here we are referencing this data collection. But why can't we just do this then? Is it the way it is referenced? We need to reference it as a reference to be able to what was it called? Dereferencing. Reference and dereferencing. And then we can modify the object. So we are changing the object itself. What a lot of back and forth we did for this simple test. If we just point to data, we can access the first element, just like that. And it is a variable, so we should be able to change the elements. But is that why, is the compiler that smart that it can see that we are actually referencing it, dereferencing it, and actually changing a value in this? So if we said const and save it, we get a compile error. Cannot assign to const. So it is actually seeing that this comes from data, which is a const, so we are not allowed to. So the other way around, it knows that this is a variable and we can change it. Oh, sorry. Inline loops. Small chapter, finally, thank you. Yeah, because right now I'm just trying to absorb the overall feel of the language, the syntax, how things are defined and initialized, but not in depth. As soon as I start a small project, I would work with it and it will get more natural for me. Right now, I'm just reading and absorbing, and yeah, I know that it won't adhere to my brain as well because I'm not really working with it. That's why I copy paste some of the tests and play around with it just to see if I understand some of the concepts, and some of them I do and others I don't. But I know that that keyword exists, or the way to do it exists, so I can dive deeper into it when I need it. So that's why I'm not, if there's some concept here I don't get completely, it's okay. Moving on, and when we need it, we'll dive into it. Inline loops are unrolled and allow inline loops. So the keyword inline loops are unrolled and allow some things to happen that only works at compile time. Here we use a for, but a while works similarly. Okay, so you can do it with a while loop as well. Using these performance reasons for performance reasons is inadvisable unless you've tested the explicit unrolling is fast. The compiler tends to make better decisions here than you. Yeah, that's something I've found out over the years, that doing optimizations, yes, sometimes you can do some optimization that is actually really good, but most of the time the compiler is so clever in analyzing the code that it will optimize it a lot better than you can do. And even sometimes when you try to optimize something, you obfuscate it for the compiler, so the compiled code will actually run slower. So just don't optimize too soon, and do benchmarking when you optimize to be sure that you're actually optimizing something and not making it worse. Const, we have a list of types, or slice. Still, the naming conventions of things, not naming conventions, just the naming of things. Is this a slice, or is it a list, or is it an array? Yeah, naming. And usize, which is just a different word for an int, right? Can we just, are we using a usize somewhere here? Yes, we are here. Let's go to that definitions. No definition found for usize. Usize is a nothing. It doesn't exist. Fair enough. I'm pretty sure that if we go to this one, U32, that's also just a type. Yesterday we did go to these buildings, yeah. But usize is apparently a, what should we call it? A basic, or yeah, missing the word here. It's something as a ground truth, or yeah, you know what, you guys know what I mean. So not only am I fumbling about the SIG language, but also the English one. Types, we have the list of types. We have this one, inline for types, capture T, so that's each type. Sum the size of T. Okay. Sum the size of T. for types. There are 4 types. What is t at this moment? It's int 32. Let's play with it. And once again we have this, and this time I found the magic button that I can actually delete a message. Let's go to the code. See if it runs. It does run. And let's look at this. Still runs, right? Yes. The size of t. Now let's just take the entire size of t and see what is in each and every value. I guess that a size is a number, right? Yeah, 4411. 44. Oh, it's number of bytes. See, that wasn't obvious to me that this actually, the size of returns the size of it in bytes and not bits. This function returns the number of bytes it takes to store t in memory. So yeah, 4411. It takes a full byte to store a boolean. So if we made a union of this, it would never be larger than the biggest one of these. So a union of these types would be of size 4 in memory. Cool. Next. Opaque. Opaque type in 6 have an unknown all byte non-zero size and alignment. Sizes and alignment. Alignment in memory, or because of this data type cannot be stored directly, these are used to maintain type safety with pointers to types that we don't have information about. Window, button, opaque, external function show window. Squeeze me? Are we already displaying something on screen? No, we don't have any of this. Yeah. But we are not getting the same errors. So let's again remember to switch to this and hopefully see if it's just differences in the setup. Copy this one. How much do we need to include here? Yeah, it doesn't know this one. I think that we need to include something more because right now we are referencing. No? Why is it? Local variable is never mutated. No, they're not. You're absolutely correct. But I don't think that's the issue. It's no. There's no members called C. Oh, is that because I'm on Linux and this is something that is Windows based? Sorry. But okay, let's see if we can understand it without test. We said a main window of type pointer to a window, but it's undefined. So we have something, we don't know what it is, but we can set pointers to it. And then we can call show window with that pointer to the window and call something on that. Opaque, a show function. So we set that to that. We know it's undefined. And we can call this show because it's a function we defined. But that calls this one. I think I get the overall idea about this. Makes it easier to interact with third-party libraries, or like I'm thinking old DLLs in Windows or something like that, where we don't know what's in there, but we know we can point to it and we can call functions on it. In some weird way, what is it? It's called in Windows. It's something with P. Yeah, I don't remember. Doesn't matter. Anonymous structures. Oh, we are getting close to the end, and then we can look at the standard library to see what's actually done for us, so we don't have to create everything from the bottom up. Anonymous structures. The structure may be omitted from a structural literal. These literals may coerce to other struct types. We have struct, point, 2 dimensions, 2 integers. We initialize 1. What's special about this one? What am I missing? We create a struct. We make an instance of that struct. That's kind of it. Okay, anonymous structs may be completely anonymous. That is without being coerced to another struct type. This is just an anonymous struct, right? It's not defined from something. We've done that before. Fully anonymous struct. And we can access by args any type. Oh, so we can use any type like this, and we can actually access the elements by name. That is very nice, because if you in C# use an object and you just stuff stuff in there, I'm pretty sure you won't get the syntax highlights and and code completion. So let's just run this code a few times to make sure. Do we get code completion? No, we do not. So we don't get the code completion because the compiler can't see what's actually in there. But if we know what's in there, then we can do this. Yeah. I like that, and I hate it at the same time. I like things to have types, well-defined types. That's why I'm not a fan of languages that are not strongly typed. I don't like Java. I don't like working with any types. I like knowing exactly what I'm doing and what types are involved. Even though one thing I'm looking forward to doing with SIG is having structures in memory or just memory that I can cast to whatever type I want. So I have raw bit information in memory and I can read it as whatever type I want. I like that idea. Anonymous structures without field names may be created. Oh yeah, here we are actually giving it names, but we can also just omit it. Indexes can be used with the plus and the dot operator. I think we worked with this before, so we know what to expect here, right? Yeah, we already had one of these. Let's see. We define this one. We don't give it names. We add two falses. I think this is from the language reference guide that we started on chapter 1. So this is very familiar. I think it's the exact same, except for the test itself. I think this structure looks very familiar. And we test that these informations are accessible. See, that's again one of the things I find kind of intriguing, because at index 0 we have this. At index 4, 0, 1, 2, 3, 4, we have a false. But how does it know how many bytes to jump for each entry in this? There must be some information. When we define it, yes, it's an unsigned integer, it's a float, and so on. So we know this is 4 bytes, this is 8 bytes. But that tells me that this is not just a structure in memory where it just lay out the information. There's some more information covered in here or added in here. So we have the information about the structure itself. So it needs to know more than just the raw data. We can check the length of it so we know how many entries are in there. We can, the value start at 3 is an H. So we are at 0, 1, 2, 3. At index 3, first element is an H, and the second one is an I. Hi. Yes. This way of accessing I really don't like. And again, why do we need multiple ways to access into an array? Can't we just use this square brackets? Apparently we can't. Yeah, we already over an hour. We are so close to finishing up, but today we only went over 1, 2, 3, 4 sections, and we have 3 left for maybe not tomorrow, but then some other day. Sentinel termination, yeah, it's a short one, but yeah, we'll look into that next time. And as always, thanks if you were lurking in the chat or just lurking and didn't say anything. That's still appreciated. I hope that it's clear that learning takes time. And this video will be, of course, uploaded to YouTube, as always, so you can comment there. I will, of course, look at every comment, as long as it doesn't, go viral and I suddenly have thousands of comments, which I do not expect ever to have. This is not made for fame and fortune or a big community. It's actually made for the exact opposite. If I could just show one person out there that is struggling with learning new stuff, letting them know that it takes time, but it's actually worth it in the end, having a new skill, both as a personal development, but also work-related and possible hires in the future. So take care, and until next time, bye.